Here are solutions to homework set number 8 for ECE 111. This homework set looks at using Matlab to solve problems that you'll encounter when you take ECE 211 Circuits 1. The first problem is given two parameters, volts between volts, amps, ohms, and watts. Find the rest. So the notation, V means volts, I is amps, R is ohms, and W is watts. So if I know the volts and the amps, take the ratio, I get resistance. Take the product, I get watts. If I know volts and ohms, then take the ratio, I get amps, volts over ohms. Volts times amps is watts. If I know amps and power, watts divided by amps gives volts. Volts divided by amps gives ohms. If I know watts and volts, watts over volts gives amps. Volts over amps gives ohms. So given two terms, you can find the rest. Problem 2. Resistors are labeled with color codes. If you know the colors on the resistor, you know what the values are. And each color represents a number. And the way it represents is the first two numbers are the mantissa, the second one's the power. So for example, gray, red, yellow is 8, 2, 4. What that means is 82 times 10 to the 4th ohms, which is 820K. If I have orange, yellow, or orange, white, red, orange is 3, white is 9, red is 2. So this means it is 39 times 10 to the 2 ohms, 3.9K. Blue, black, green. Blue is a 6, black is 0, green is 5. So that's 60 times 10 to the 5th ohms, 6 mega ohms. Problem 3 looks at Kirchhoff's law. Kirchhoff's law says if I take a closed path and measure the voltages, if I wind up where I started, the sum of those voltages must be 0. So this is kind of like a Sudoku puzzle. I want to find a path where there's one unknown. So for example, here's the path. I get minus 100 plus 7 plus D equals 0. That tells you that D is 93. Over here, minus 93 plus 9 plus E equals 0. That gives you 84 volts. Last one, minus 84 plus 24 plus F equals 0. This must be 60. Around this loop, minus 80 plus 6 plus A minus 7 equals 0. So that would be 81. Around this loop, minus 81 plus 18 plus B minus 9 equals 0. So what's that? That's 72. And then minus 72 plus 35 plus C minus 24 equals 0. This is 61. And the thing to note, this works for any closed path. If I were to take this path, add them all up, since I wound up where I started, all this has to add to 0. So any closed path, if you add up the voltages around any closed path, the total has to be 0. That's called conservation of voltage. And here should be the answer. Problem 4 looks at conservation of current. Conservation of current says at any node, current in equals current out. So at this node right here, I've got 57 amps flowing in. I have to have 57 amps flowing out. So this is 57. At this point, 57 are going in, 57 has to leave. 45 goes right, which means that 12 has to go down. 45 goes in, 45 goes out. 42 went right, I'm missing 3, so B must be 3. 42 go in, I have to have 42 out. Here's 24, the remaining 18 is right here. 24 in, got to be 24 out. For E, 43, 55 go in, I have to have 55 going out. So here's 18. 37 plus 3, 40 going in, I have to have 40 going out. Here's 14. 44 going in, I have to have 44 going out. So this is 27, 17 and 24, 41 going in, this has to be 41 going out. And when you're done, at the last node right here, 100 go up, I have to have 100 going in. So here's the answer. Problem 5. Find the total resistance. Now, here's the trick. When you're in series, that means the current through the first resistor, all of it goes through the second. When you're in series, the resistance adds. When you're in parallel, which means that the voltage on one side is the same, voltage on the other side is the same. The resistances add as the sum of the inverses inverted, kind of like this. The trick is to simplify the circuit by combining resistors in series and parallel. So in Matlab I can do that. Find two resistors in series. So 200 and 300 are in series, call that R1. R1 is 500. Now 500 is in parallel with 700. So take the inverses, add them, take the inverse. All this together gives you 291. These two are in parallel. 400 in parallel with 600 is 240. It's these two. Now these are in series. I've got 240 in series with 291. They add. All that together gives you 531. 500 is in parallel with 531. Combined, those two combined gives you 257. Again, take the inverses, add them, take the inverse of the answer. And finally, 100 is in series, add 100. The total is 357. Now, just kind of a word of advice. When you get to circuits 1, this is a typical test question. You need a calculator that can do this. Matlab can do it, but you typically don't have Matlab on tests. Have a hand calculator that can do these calculations. I recommend the HP42s, but it's totally up to you. Just make sure your calculator can do this type of calculation. And to illustrate that, I'll go through this. I'm going to show you how fast the HPs are. Now the HPs do not have an equals button. It uses a stack. When I add, subtract, multiply, divide, it's operating on the stack. So first I want to add 200 and 300. Let's go 200, push that on the stack, 300. These two add. Now in parallel with 700. So take the inverse, type in 700, and notice it just did a push automatically. Inverse of 700, add the inverses, there's 291 ohms. 400, enter, scroll down, 400, take the inverse, 600, take the inverse, add them, inverse. These two together give you 240. And notice the stack is still set up. Stack remembers the old operations. These are in series, they add 531 ohms. In parallel with 500, so take the inverse, 500, inverse, add inverse, 257 ohms, in series with 100, 357. So again, you don't have to use an HP calculator. Use whatever you want. Just make sure you can do this on a test. Problem 6. I can check my answer. Now there are websites called like Chegg and AI that will solve problems. You don't need them. There is Circuit Lab. Circuit Lab is just a beautiful program, free to use for all NDSU students. You have to use your NDSU email address. So you have the @ndsu.edu. There's also NDUS. This is for the entire university system in North Dakota. That covers NDSU, UND, Bismarck State, Dickinson State. NDSU doesn't pay the site license for their students, so likewise that's not accepted. You have to use your NDSU email address to get in. Similar for Matlab, got to use your NDSU email address, and then it's free. Everyone else has to pay. In Circuit Lab, I can build the circuit and test it. If I apply a 10-volt test signal, find the current going in. 10-volt test draws 27 milliamps. that tells me the resistance. From V equals IR, 10 volts at 27 milliamps is 356 ohms. Same thing with a little bit of rounding. Repeat. Here's the circuit. What's the total resistance? Again, the trick is to find series and parallel. These two are in series, so that gives you 340 ohms. 340 is in parallel with 200, gives you 125 ohms. In series with 30, gives you 155 ohms. 155 in parallel with 100 gives you 60 ohms. In series with 20, gives you 80 ohms. So there's the total resistance. Again, I'll show you with an HP calculator how you do that. I'll take 40, try it again. 40, enter 300, add them. I could actually do that in my head. In parallel with 200, take the inverse, 200, inverse, add inverse, 125 ohms. In series with 30, 155 ohms. In parallel with 100, take the inverse, 100, inverse, add inverse, 60 ohms, plus 20, 82.92 ohms. Check your answer. To check it, I'll throw it in Circuit Lab, build the circuit, apply a 10-volt test, find the current. The resistance then is voltage over current. 10 volts is 123 milliamps. It's 80 ohms. Same answer. The last two problems look at voltage division. Find the voltages using Matlab. So with voltage division, it's what I'm measuring divided by the total. So know that V3 is what I'm measuring, 300, over the total resistance, 300 plus 40, is that percentage, V2. V2, let's call this guy R2. The total resistance looking right at this point, which is 340 in parallel with 200. V2 then is R2 over the total, R2 plus 30, is that percentage of V1. V1, take this point looking right, the resistance, call that R1. Once I know R1, then V1 is R1 over the total, R1 plus 20, that percentage of V0. So that's the trick. Find these resistances. This one's 300. R2 is 340 in parallel with 200. That's 125 ohms. Plus 30, that in parallel with 100 is R1. So R1 is 100 in parallel with RB, R2 plus 30, 60 ohms. I can now do voltage division. V1 is R1 over R1 plus 20, that percentage of 10. V2 is R2 over R2 plus 30, that percentage of V1. And V3. Checking my answer, I can throw that in Circuit Lab and get the same answer. So that is homework set number 8 for ECE 111. This is kind of the basics behind circuit analysis. You don't really need to use Matlab on homework set number 8. When you have one equation, one unknown, a hand calculator works. When you get to two equations, two unknowns, that's when Matlab really shines. That'll be next week. But for now, that is homework set number 8 for ECE 111.